Okay guys, so today we're going to be solving, you're going to use the square root at the end, okay? So we are trying to isolate our variable. And get it alone. Oops, there it is. Okay, so in every single problem that you're going to have to take the square root. Here's something that we need to talk about for square roots before we even begin. If you have an area, not in real life, in math world, if I have an area of a square, okay, so the area of the square you get by multiplying each side together, and on a square, all sides need to be congruent. They all need to be equal. So for example, if this square had a 3 as one of its sides, well, I know that this side is 3, and this side is 3, and this side is 3. To figure out the area of this square, we would multiply 2 of the numbers together. So 3 times 3 would be 9, and it's a positive 9. Now, here's the theory. In math land, or just using numbers in general, if I had a square whose side length was negative 3, well, that would mean that this side length would be negative 3, this side length would be negative 3, and this side length would be negative 3. In order to figure out the area of this square, we would also multiply two side lengths together, negative 3 times negative 3, and get a positive 9. So if I think that my root of my area 9 is a positive 3, well, it could easily be a negative 3 as well. Again, this doesn't happen in the real world because our numbers are nice and pretty when we measure distance. However, you need to have both answers for what's coming up in the future. So, if I'm asking you for the square root of 9, technically your answer could be a positive 3 or a negative 3, because 3 times 3 is 9 and negative 3 times negative 3 is 9. And you're not sure exactly what answer, and it kind of depends on like the context of the situation or the like the words or the problem that's happening. But right now we don't know any of that. So we have to guess that this could be our answer or this could be our answer. So for all of these problems, you're going to have two answers because a negative times a negative is a positive and a positive times a positive is also a positive. So that's why. Okay, so just keep that in mind. You're going to have a positive and a negative version of every answer that you do. Now, you need to know a brand new symbol. When we write a positive and a negative, it's kind of annoying to write a number and then the other number when the answer is the same number. So instead, mathematicians came up with this symbol that looks like this. This means positive and minus, or positive and negative version of this answer. So this means positive 3 and negative 3. Okay, so you're going to see the symbol a lot from now on, starting today. Okay, so we're trying to get our variable by itself, so we need to do the opposite of plus 10. So we're going to be subtracting by 10 on each side. So now we have 7p squared equals 63. Okay, so we need to keep solving, so we're going to divide each side by 7, and p squared equals 9. Well, this just falls in line to what we just did. In order to get the p by itself, we have to do the opposite of squaring. The opposite of squaring is taking the square root. What we do to one side, we must do to the other side. My root and my square cancel, leaving just my p. And then this, the square root of 9, could be a positive 3 or a negative 3. So for our answer, we're going to write plus minus 3. And there we go. Okay, so you just have a bunch of different types of problems like this. Now, number 3. Number 3 is a little bit trickier, but you can solve it because we've been working with imaginary numbers. So the first thing we're going to do is we're going to add 1 to each side, again trying to isolate our variable and get it by itself. Okay, so now we need to divide each side by 6. We have p squared equals negative 59 divided by 6. Okay, we're going to keep going. So we have the square root of p squared and the square root of negative 59 over 6. Those cancel. Okay, so now I've got p equals the square root of negative 59 over 6. There's a few things going on here. The first thing I notice is I have a negative in my radical. So if I have a negative in my radical, I'm going to get rid of my negative and make an I. Okay, so I'm going to have an I attached to the end, and we're going to just put it at the very end this time. Okay, now this really means that I have the square root of 59 over the square root of 6. Well, I can't take the square root of 59, and I can't take the square root of 6. We also have to remember that we have like a plus minus out front and an I behind, but we're just going to let that hang for a second. Okay, I can't leave a radical in my denominator, so I'm going to multiply the top by root 6 and the bottom by root 6. When I do that, the square roots on the bottom cancel, leaving 6, and then on the top, I just have to multiply. 59 times 6 is the square root of 354, and that does not reduce. So since this does not reduce, then I can put my final answer together. I took a square root, I added a square root to help us solve our answer, so that means that I need to have both the positive and the negative version of this answer. Also, I took out an I because of my negative 1 underneath my radical, so I also have to put an I in at the end. So my two answers are positive square root of 345 divided by 6i and negative 345 divided by 6i. Okay, so that's one answer. These are the two answers together. If you wanted to see them written down, which is just what I read off to you, this is technically one answer, and this is technically the other answer. Okay? All right, this one's probably one of the trickier ones, so there you go. Okay, let's do number 7. Number 7 has a similar idea. We're still going to start by subtracting by 8 on each side. So now we have 25x squared equals 64. Then we're going to divide each side by 25. Now, I'm not going to finish and divide, even on numbers that would divide. These guys just hang out. But on numbers that would divide, I'm just going to wait. So let's write the next step. We have x squared equals 64 over 25. To get rid of the squared that's attached to my x, I need to take the square root so that it cancels. What I do to one side, I must do to the other. And actually, this one's really nice because then you have x equals, then I've got the square root of 64 on the top and the square root of 25 on the bottom because you have to break it up into 2. So then that gives me the square root of 64 is 8 and the square root of 25 is 5. Also, I need a plus minus on these guys because it was two answers. You could have the positive version of 8/5 or the negative version of 8/5. Let me do another one for you so you can see how we're doing this. You can catch on a little. It seems really tricky, but it's really not that bad. All of the answers, sorry, just an aside, all of the answers on your quiz today say A, B, C, D. Okay? So you're going to have to tell me what A, B, C, and D equal. Now, I didn't put a number on a shelf because these are all square root. So you'd write a 2 in for all of them, and I just didn't think that was necessary. A stands for the leading coefficient. Okay, so here you could, okay, so here you could write it two ways for this problem. This problem isn't the best example. Let's look at this example. So for this guy right here, A, I don't have anything in front, so if I don't have anything in front, it's a 1. B, under my radical, is 354. C is 6, and then D is going to be I. So if you have an I, you put an I in for D. If you don't, you put a 1 in. If we were looking at this first problem right here, it's just plus and minus 3. So, oh wait, sorry, I forgot to tell you. I've included the plus minus on the problem, so you don't have to worry about that. So just put the leading coefficient. So here, all we have is 3. So A would be equal to 3. Now, I don't have a radical, and I don't have a fraction, and I don't have an I. But if I didn't want to change 3, these would all be 1. So that's what you'll fill in for pieces that aren't there. Now here, that brings us back to this guy. So this guy could be taken as two ways. The 8 could be the A, and the 5 could be the C. Or I would accept it as the A being 8/5, and then B, C, and D would all be 1. Whatever you'd like to pick, I'll accept either answer. Okay, so let's do another one. Let's do number 8. Okay, on number 8, so we're going to get this x squared by itself. we're going to do the opposite of subtract 10, so we're going to add 10 to each side. I have 9x squared equals 864. Then I'm going to divide each side by 9. And now I have x squared equals 864 divided by 9. Again, I'm just going to let it go. Don't try to simplify yet. Okay, we're going to take the square root of each side. And now we have x equals plus minus. And then I have my radical 864 all over 3, because the square root of 9 is 3. Okay, so now let's look at the top. 864. So that reduces to 12/6. Okay, so if I keep going, I have plus minus 12 root 6 over 3. Well, 3 goes into 12 4 times, which makes the 3 underneath gone. And then I've got a 6 and a plus minus. This is your answer. Okay, so again, my A would be 4, my B would be 6, my C would be 1, and my D would be 1, because I don't have a fraction underneath and I don't have an I. Okay. So reduce first, and then do the problem. I'm trying to think if there's anything else that I could show you. All of those other problems are really similar to the ones that I just did. If you have any questions, let me know. This is kind of-ish new, and it's combining old ideas with new ideas, so I get how it can be a little crazy. All right, so let me know. Have a great day, guys. Bye.